Hello everyone, and welcome to our introduction to auxiliary views. Today we'll explore some of the basic information about auxiliary views. Let's start by answering the question that most of you have right now, and that's what is an auxiliary view? An auxiliary view is an orthographic view. You will recall that we have studied the 6 principal orthographic views. Shown by this glass box here is the top, the bottom down here, the front here and the back, the right and left projection views. These views, as we have seen, use orthographic projection to represent a three-dimensional part in 2 dimensions. It does this by projecting the object onto the view orthographically or at right angles. Now, an auxiliary view is an orthographic view, but it is an orthographic view other than one of the 6 principal views. That's a really easy way to understand. Note that the features of the object, and here's the object here, which are parallel to the primary views, project orthographically to give the true shape and size of the features of the object. And so here you have the front view, which is the glass box here in the front, and the features located here on the object. And notice that they are parallel. Okay, the features here and the front projection plane are parallel. And so when we project onto the projection plane, what this will do, because they are parallel, will produce a projection that is in the true size and true shape of the features of this object. But note that this feature, which is the inclined plane, is not parallel with one of the 6 principal projection planes. And as we project it, it points out to the right projection plane, perpendicular to that right projection plane. As I do that, you'll notice that it produces a projection that is shorter. This distance BC and AD is shorter than this distance here, BC and AD. We say that then this projection is foreshortened. Likewise, we see the same effect on the top view. As we project A, D, and B, C up to the top projection plane, it produces again a projection that's foreshortened and is not the true size of the inclined plane. So what do we do to get the true shape and size of the inclined plane? Well, we must choose a view other than one of the 6 principal views, or in other words, we must choose an auxiliary view. Note that this is the auxiliary view shown here, and it has been purposely chosen or drawn so that it is parallel with the feature of interest, this inclined plane. So it's parallel with the inclined plane. And it's done purposely such that when we project orthographically or at right angles these features onto the auxiliary view, you see, it will produce the true size and true shape of the inclined plane. Now, this is one of the reasons why we use auxiliary views, to find the true size and shape of features not parallel to one of the 6 orthographic views. Well, I hope you found this helpful as an introduction to auxiliary views. I'll follow this up with a post. Please post your thoughts, insights, and any questions that you might have. Have a great day, guys, and see you in the threads.